Alright guys, I'm back again to make another video, and this one is hair fun facts video number 3. And today, like I promised, we're going to be talking about hair bonds and I guess how the structure of the hair is held together. And in my other video I told you that hair is basically dead keratin protein that's wound together in a helical structure that gives us these like little ropes of keratin versus the sheets of keratin like in our fingernails. So hair has two types of bonds. The first one we're going to talk about are the hydrogen bonds that hold hair together. And hydrogen is in like everything. It's in water, and it gives things different properties, and that's, you can go back to chemistry 101 or 121, or whichever one you took. But basically, the hydrogen bonds that are in hair are the easiest to disturb or the easiest to manipulate. And you can see that manipulation with, for example, heat. When you flat iron your hair or when you blow it out, you're basically rearranging those bonds to kind of stretch the hair out. And then when you get in the shower and you get water in your hair and the water interacts with the hydrogen bonds, it resets things into its original pattern. Now, another thing that kind of alters the, I'm getting lost for words, the structure of the hair or the hair hydrogen bonds, twist outs. When you twist your hair and you're kind of like molding it into a shape, you're kind of rearranging the hydrogen bonds just from pressing the hair together. Roller setting, anything that kind of molds your hair into a new shape than what it originally is, that's just basically affecting those hydrogen bonds and redistributing them in the way that you want the hair to lie. And it always comes back when you add water, most of the time. Now here's my thing. Something that happened to me was with heat damage. And what I think happens with heat damage, my theory on heat damage, is that over time, because the hydrogen bonds, with you using heat, it shouldn't be a permanent disruption in the hydrogen bonds. When the water hits it, because hydrogen bonds are what give us our elasticity, that when you stretch your hair down, it boings, that boinging, that's hydrogen bonds that you're stretching and letting them boing back up or whatever. Over time, with repeated heat applied to your hair, repeatedly disrupting those hydrogen bonds, I believe that you actually permanently break or disturb the hydrogen bonds so that when you do apply water to your hair, it will not revert back. And it's kind of a gradual thing. It's not like, well, I have heard of some stories where people have just went to get their hair pressed and their hair did not revert back to what it was before. But it can be a gradual process. If you're somebody who washes and blow dries your hair every day, well, not every day, hope no one does every day, washes and blow dries your hair every 3 days or every week or something, gradually over the course of the year, you're going to notice that your curl pattern is going to be a little bit looser. And that may be a problem for you, it may not be a problem, but what you're doing is you're losing the elasticity. And when you lose elasticity, that stretching effect of the hair, you're more prone to breakage, so that instead of when you comb your hair, it's stretching out, instead of stretching, which wet hair can stretch to about 50% of its length, and dry hair can stretch to about 20%. You could take a strand of hair and actually slowly pull it apart, and you'll see it stretch, and when you let go, it slowly winds back up. But I'm getting off topic. So when you lose the elasticity in your hair over time, instead of when you combing your hair and it's stretching, it's gonna stretch and pop, basically, is what you're doing. So elasticity is really, really an important property of hair, especially if you're trying to grow your hair long, because you don't want the strand, every time you're growing out your ½ inch a month, it's popping off the other way. It's not gonna work. So that's hydrogen bonds. The next type of bond is a very strong bond that's very difficult to break, the cysteine bonds in hair. And cysteine is held together by sulfur bonds, disulfide bonds. They're two sulfur atoms stuck together. And these bonds are broken by products like sodium hydroxide lye that's found in relaxers. They actually disrupt those bonds, and then they cap them because it's like a acid-base reaction. The relaxer is like a basic substance. Bases can burn too, because I know y'all have seen some relaxer burn. That's a whole nother lecture. So you put the base on the hair, it kind of makes it all limp and noodly, and then you use a neutralizer, which is a shampoo that's like acidic, which means the pH is very low, to balance things out, to bring it back to hair's normal which is around 7, a little over 7. It's not quite with water. Hair is a little bit on the basic side, but basically that's what you're doing. And that's basically breaking those two sulfur atoms apart, capping them off. They're not allowed to come back together again. You're like smoothing the hair so it's laying straight, and that's how you have it. And all hair has hydrogen and the disulfide cysteine bonds, but the disulfide bonds are going to vary depending on the hair type. Of course, the straighter your hair, the less disulfide bonds you have. That's why your hair is straight. The curlier, the kinkier your hair is, the more it contracts down, the more disulfide bonds you have. Okay? And we talked about how relaxers break the disulfide bonds to allow the hair to be molded straight. Well, how will you get hair to go from curly to, to go from straight to curly? You do the opposite. You use products that add disulfide bonds to the hair to get it to curl. I didn't know that. I learned that the other day, and now you guys have learned it too. Isn't that great? So if you guys have any questions about heat damage, relaxer damage, curly perms, I'll try to answer them as best I can, or anything that you guys might think or you have an idea for a different video, let me know. It was great talking to you guys and hope you enjoyed the lesson. Bye!